All right, guys. So it appeared lots of us, not everybody, but lots of us were struggling a little bit with the energy math stuff. So I thought I'd do a chemistry tactic here and put up a tutorial video for you guys. So I'm going to walk us through a few problems, step by step, kind of explain the logic that goes in some of the calculations. So when you guys are taking a look at my key, you're figuring out where all these numbers are coming from and why I'm putting them in this little table and what I'm doing with those units and all that stuff, okay? So what we're gonna work on together for these is number 2 and number 3 first, because that kind of sets the stage for some of the later problems. Then we will also do number 8 together. And then if this video is not getting too long at that point, we'll also try to work our way through number 9. All right, but at least 2, 3, and 8 should be a good start for us as we go through this, okay? And keep in mind, this is intro to energy math, and so you guys who haven't had chemistry or physics yet, lots of this new unit stuff might throw you for a loop, okay? Anyways, so I kind of put abbreviated forms of the questions up here just as a guide, so as we go through, I can refer to that and I have to keep looking at my paper. But number 2, all right, what they want us to do for that one is to convert 1 kilowatt hour into kilojoules, all right? Now, I wrote in parentheses 1 watt equals 1 joule per second because they give me that conversion right there at the top of my first page, okay? So what I want to do then, is take this unit, kilowatt hour, which is a unit of energy because it's got a unit for power and time, right? So power times time is energy, all right? And kilojoules is also a unit for energy, all right? And so this unit, 1 watt, is equal to 1 joule per second, all right? So there's that time value considered for our energy use, okay? A watt is just a unit of power, so we have to go watts times hours or something like that to get it to get watts into an energy measurement instead of just a power measurement. Okay, so if I have a kilowatt hour, which is a unit of energy, all right, I want to know how many kilojoules that is. So nice thing about this conversion, if 1 watt equals 1 joule per second, 1 kilowatt would equal 1 kilojoules per second. Okay, so number 2, I'm going to write this: 1 kilowatt equals 1 kilojoule per second. All right, so at face value, it looks like, oh, that's just a 1-to-1 conversion there. Now, the trouble is, this is kilowatt hours, and this is kilojoules per second. All right, so what we have to do then is, kilojoules is great, that's the unit we want, but we want kilojoules per hour in this case, right? So we're going to have to convert seconds over to hours because this is hours. This is a kilowatt second. It'd just be a 1-to-1 conversion. All right. So what I'm going to do is I'm going to set up my given quantity, 1 kilojoule per second, as a fraction. So I'm going to write 1 kilojoule over 1 second. Okay. So 1 kilojoule per second can be written like as a fraction like this. Now the reason I do that is it puts my units in their correct placing, and then I can go and do some unit converting and show how I'm canceling from one unit to the next and so on. All right? And so this line across, we just treat this like a fraction. So whatever's on top can be divided by what's on the bottom, but it's just 1 divided by 1 there. All right? So I want kilojoules per hour, right? See that unit there is hours, right? So I'm essentially going to have to convert seconds into hours, right? You could just go direct conversion, but I'll go to minutes first and then hours just to kind of show you the unit cancellation process, okay? So 1 kilojoule per second, kilojoules is on top, right? So again, this is essentially how I want to get my answer, kilojoules per hour, right? Because of the hour sign there, all right? So to cancel out seconds, I'm going to have to put it on the opposite side of this line. To cancel units, right? If you get the same unit on top and bottom of a fraction, we can cancel them, all right? So what we're going to do is we're going to convert seconds into minutes. Now, how many seconds are in 1 minute? 60. All right? So now I can cancel my seconds, right? Now my units are kilojoules per minute, all right? And we can do the same process then to convert to hours. So minutes here, hours there, all right? How many minutes in an hour? 60 minutes in 1 hour. and I can then cancel my minutes. So the units that I want in my answer right here, kilojoules per hour, sorry, that's an H, a horrible looking H, but it is, right, are now showing up on my table. I've got kilojoules over hours, right? So now what I do is, this is where my calculator comes in. I'm just going to go 1 times 60 times 60, right, which would be 3,600. And these are all ones on the bottom, so I don't have to divide by anything. So this would be 3,600 kilojoules per hour. Okay, so 1 kilowatt hour is equal to 3,600 kilojoules per hour. Is how we would read that. Okay, so all I'm doing with this table is essentially I multiply across the top and I divide by what's on the bottom, and that's how I set it up. Okay, now this 3,600 kilojoules, I'm going to write this conversion up here because it's going to come in handy. 1 kilowatt hour equals 3,600 kilojoules. Okay? That's our direct conversion there. Okay? So our next question then is we're going to put this kind of to use. Again, I'm leaving this little conversion up here. It'll come in handy. 1 kilowatt hour is equal to 3,600 kilojoules. All right. So our next conversion, number 3, says, assume your electric bill showed you used 1,355 kilowatt hours over a 30-day period. All right. And so 3A, B, and C here asks us to do some different things with those numbers. So 3A, okay, it says find the energy used in kilojoules. All right. Okay. Now, the reason I left this conversion over here is I didn't want to have to go through all that math again to convert kilowatt hours to kilojoules. We know 1 kilowatt hour is equal to 3,600 kilojoules. All right. So we're going to use that conversion in our next step here. How many? So 1,355 kilowatt hours is how many kilojoules over that 30-day period. Okay, so what we're going to do is take our quantity, our given quantity, 1,355 kilowatt hours over 1. Right? Now you don't have to put a 1 there. I just like to put a 1 there to show that I'm not putting another unit on the bottom. Right? You could just leave it blank if you want. All right. So this is just kilowatt hours. I'm not worried about this 30-day period because that 30-day period doesn't change in this question. All right. So that many kilowatt hours over a 30-day period. How many kilojoules is that over a 30-day period? So I don't include that in my math for this step. Okay. So what I do then is I want to convert kilowatt hours into kilojoules. So if I want to get out of kilowatt hours, it needs to go on the opposite side of my fraction. So 1 kilowatt hour is equal to 3,600 kilojoules. Okay? And then it's a simple multiplication problem. 1355 times 3,600, right? Canceling out my kilowatt hours, my answer will be in kilojoules. And when I do that multiplication, I should get 4.88 times 10 to the 6th kilojoules. Okay? And that would be my answer for letter A. Okay? B. All right? Find the energy used in joules per day. Now, this is a little bit tricky. So first of all, this is 4.88 times 10 to the 6th kilojoules per 30-day period. So how many kilojoules would that be in a single day? And then we want to convert the kilojoules into just joules. All right? There is a value on that first page that says 1 kilojoule is equal to 1,000 joules. Okay, so there's another conversion we'll get to in just a second. Okay, so it says find the energy used in joules per day. So I've got my kilojoules per 30 days here. So now watch what I'm going to do here. 4.88 kilojoules. So I want in my answer, I want joules over days is how I want that to look. Okay, so I've got 4.88, times 10 to the 6th kilojoules. All right, now I use that amount of energy over a 30-day period. right? So I can write over 30 days, right? Because that's the period of time it took to use that amount of energy. And I want days as part of my calculation this time, all right? So 4.88 times 10 to the 6 kilojoules per 30 days is how I write that, okay? Now, I've got my days on the bottom where I want it. So I don't need to do anything with that unit. I just need to divide by 30 when I'm ready, okay? So what unit do I want on top? I want joules on top. So I'm going to have to cancel my kilojoules and convert that to joules, all right? Now on the first page, at the top, it tells us on that very first line, 1,000 joules equals 1 kilojoule, all right? So I'm going to take that conversion, again, right at the top. 1,000 joules is equal to 1 kilojoule, all right? Now, out of kilojoules, my units now are joules over days. Joules over days. That's what I want, okay? So, I'm going to take this times 1,000, put that in my calculator, divide that by 30. So that times that equals, divided by 30 equals, and I should get 1.63 times 10 to the 8th joules per day. All right. Now, when you guys punch these in the calculator, you might get slightly different numbers. I'm just rounding them. All right, for those first two decimals. It's pretty commonplace. There are rules we can use with sig figs and stuff like that, but that's really kind of beyond the scope of what we're doing. Okay. So, then letter C. It says, at the rate of $7.49 per kilowatt hour. Sorry, excuse me. 7.49 cents. So it's 0.0749, right? So about 7.5 cents approximately per kilowatt hour. Okay? So that's the price we're paying for each kilowatt hour that we use, right? So again, when your parents get the electric bill, their meter, that meter outside your house with that spinning wheel, or it might be digital, right? That counts essentially the number of kilowatt hours being used over whatever billing period they give you. It's usually a month, okay? So in this case, each kilowatt hour is about 7.5 cents, or 7.49 cents, or $0.0749, okay? So if you get a dozen donuts, each donut's $1, right? You're gonna pay $12 for 12 donuts, right? So in this case, we have that many kilowatt hours. Each kilowatt hour is 7.5 cents. So we just multiply those two numbers to get the price of that, okay? So if I want to show units, just because that's a good practice to get into, I would just set it up like this. I'm going to go 1355 kilowatt hours, right? Times $0.0749 per 1 kilowatt hour, right? So my answer will come out in dollars. So I multiply that by 0.0749, I should get about $101. All right. So that much electricity, it's actually kind of a lot for a house. Must be a big house, right? Or it has electric heating in the wintertime or something. Anyways, that much electricity consumption, so that means energy use in this case, would cost me about $101 for that month at 7.5 cents per kilowatt hour, which is actually really cheap for electricity. Really cheap. Okay? So that's 2 and 3. I'm getting a little long-winded on you guys, and I'm sorry, but I really want to try to drive some of these ideas home. All right? Next one we'll work on here is number 8. Okay? So for number 8, skipping ahead. Right, it says, suppose your electric light uses 400 watts per hour and an average 4 hours per day, each day for 1 year. All right? So they worded that question a little weird. I know I copied and pasted these questions. I probably should have edited. 400 watts per hour, it's really 400 watt hours, okay? Or 400 watts times 4 hours a day. So over the period of an hour, 400 watts are being used. So 1 hour would be 400 watt hours. 4 hours would be 400 times 4 hours. Okay? Anyway, so the semantics there, I know, but it does matter. Okay, so lights use 400 watts for 4 hours each day for a year. That's what we're starting with. So what we want to figure out is how many kilowatt hours per year does this represent? Okay, so to get daily use, 400 watts times 4 hours, okay, will be watt hours. Okay, so I'm just going to do this. I have 400 watts times 4 hours per day. Okay, so 400 watts times 4 hours per day. All right, and what that will give me is watt hours per day. So that's my units. I can't cancel anything just yet. Okay, but that does get us started on the right track for where we want to end up going. All right, so far, 400 times 4, so about 1,600 watt hours per day. Now, what I want to figure out is how many kilowatt hours is that over a year-long period. So in my answer, right, I want kilowatt hours over years, right? 'Cause that's what it asks me. How many kilowatt hours per year? So in my answer, so what I want to be left with, I want kilowatt hours on the top, I want year on the bottom, right? So far I have watt hours on top and days on the bottom. So I'm going to have to convert days to years and convert watt hours to kilowatt hours. Okay? So it doesn't matter which conversion you do first. I'll go ahead and do the watts to kilowatts because that's an easy one, right? So the prefix kilo means 1,000. So watts to kilowatts, right? Again, if I want to get out of watts into kilowatts, I have to put the watts on opposite sides of the fraction. Plus, I want my kilowatt on top anyways, okay? So, how many watts are in a kilowatt? 1,000 and 1 kilowatt, okay? Now, if I was to just keep track of my units, now I'm in kilowatt hours per day, all right? So, the units that I want on top, kilowatt hours, that's done. I've got kilowatt hours on top. Now I need to go convert my days into a year, all right? So I want to cancel out days, right? The day goes on the bottom there, so that means it's on top there, okay? So that allows me to count, and then on the bottom I can put year. So how many days are in a year? 365 in 1 year, right? Boom, bam, all right? So keeping track of my units again, I've got kilowatt hours, kilowatts times hours on top, year on the bottom, which is what I want in my answer, okay? So now 400 times 4 times 365 equals, divided by 1,000 equals 584 kilowatt hours. Okay? That's letter A. Letter B. Okay, it says if replacing the lights with fluorescent bulb would save 40 or say 60 watts per night, what savings in kilowatt hours does this represent in 1 year? Okay, so the way we want to set this up per night, right? So essentially that's per day. So 60 watts total per day. So what we want to do is figure out what fraction of our total energy is that. Okay, so in the case of number 8 here, we're going to say 60 watts per night. And how much are we using in a day? 400 times 4, so 1,600 watts, right? So 60 watts over 1,600 watts. Sorry, excuse me. Sorry about that. 60 watts over 400 watts. Sorry about that, okay? I got my units confused. I wasn't paying attention. That would be watt hours if I multiply those, right? I have to compare like units. So 60 over 400. Sorry about that. Caught myself. That's why units are important. Okay? So 60 over 400. Sorry about that. Don't need another step there. And what I get is a fraction of 0.15 or a factor, right? Or 15% maybe is a better way to express that. It's a little bit more what you guys are probably used to, right? So what I'll be doing is saving 15% of my electricity for lights by switching over to fluorescent bulbs. Okay? So with that, how many kilowatt hours does this represent? All right? In savings. All right? So here's how many I used with the old school incandescent bulbs, 584 kilowatt hours, right? If I save 15% of that, that's how much I'm saving, right? So it's a simple multiplication problem now. It's going to be 584 times 0.15, right? And that would be equal to 87.6 kilowatt hours per year are saved. All right? So I'm essentially going to use that many fewer kilowatt hours in a year by switching to fluorescent bulbs, which are more efficient in terms of how much light they put out. Okay? So, letter C then asks the question, right? If the fluorescent bulb costs $18 but lasts for 10 years, would you consider it a wise investment over incandescent bulbs, and explain your answer? All right, so I'm going to erase part A here so I've got space. So this is how much we're saving. All right? All right, now in question 7, right, I'm going to throw in an economic question here. All right, so in question 7, it said assume a cost of 8.25 or $0.0825 per kilowatt hour. So we're going to use that. All right, we use that value instead of the 7.5 cents because that was on the more recent question. And that's actually more realistic for price of electricity anyways. All right, still really cheap, by the way. All right, so that's how much we're paying per kilowatt hour. Okay, this is how much we're saving in kilowatt hours per year. All right, we want to basically see, hey, if those darn fluorescent bulbs cost 18 bucks a bulb, is it really going to make sense cost-wise to make that switch? Okay, because electricity is not very expensive at that rate. So let's do the math. Let's see if we can figure out, does that actually make sense financially? All right, so here's how we're going to do that. We're going to take our 87.6 kilowatt hours saved, all right, per year. Now, how long do the bulbs last? 10 years, all right? Now, that's important to us. So I'm going to say 87.6 kilowatt hours per year, right, times 10 years, 876 kilowatt hours. All right, so over the 10-year period, I'm going to say 876 kilowatt hours. All right, it's actually a very sizable chunk. We're starting to get into some actual monetary value there. Okay, now, how much does that actually amount to? Right, so 876 kilowatt hours, right, times 8.25 cents per kilowatt hour. So I'm going to do this. Next step, 876 kilowatt hours times $0.0825 per kilowatt hour. And what that gives me is $72.27 in savings. Okay, over 10-year period. Now, $72.27 over 10 years, that's really not that significant of a chunk of change, right? Comes out to less than $8 a year. Okay, 723. All right. So now the question is though, does it make financial sense to pay $18 for a bulb? Okay, are we going to save enough money in the long run to make that a viable or a wise financial decision? All the environmental concerns aside. Okay, so how many bulbs would that buy? That would buy about 4 bulbs, right? If you divide 18 into 72, it comes out to about 4. All right, so did you buy 4 bulbs, 4 100-watt bulbs, so you could essentially get all of your lights, right, for 72 bucks, right? So you save $72.27, so you pretty much break even. All right. Now, of course, if we factor in the cost of the incandescent bulb, which is a couple dollars a bulb, it actually comes out to even better. So, does it make sense financially? Yeah. Right. You don't not out anything. In fact, you probably save a little bit of money over the 10 years. Now, is it enough to make that big of a difference in your bank account? Probably not. But it certainly doesn't make a financial burden out of the whole thing. Okay? I'm getting really long, so I'm going to cut myself off right there and not do number 9 with you guys. Sorry. Hope this helps.